that will convert them to the proper size. Okay? Okay, so that's the forgetting gate. Check out the remember, this like remember section here. So what is it doing? See if you can just intuitively understand it based on what we've already talked about. So I'm going to take a stab at explaining this and what's going on. Go ahead.
So it has the sigmoid on the left and the
Okay.
tangent on the right.
So sigmoid on the left,
It's kind of like
tangent here.
a gate to say how much of the new state we want to remember, it seems like.
Yes. Right, so this is learning like a mask.
Yeah.
This is saying for each entry in my state vector, I'm either going to remember something or I'm not going to remember something. If this is 0, what happens?
You don't remember.
Whatever this spits out doesn't matter. But if this is 1, what happens? Then whatever this spits out gets plugged in up here. So yeah, so this is learning what to remember, and this is learning sort of a mask that controls whether or not to remember it. So it's sort of what I should remember and whether or not I should remember it. And those are two distinct paths. Those are two distinct things. Yeah, go ahead.
What's the difference between the blue input and the orange input?
Okay, so the orange, so I think of, yeah, the orange input is another hidden state. And I like to think of this as, well, it's called long and short-term memory, LSTM. There's actually, you can sort of think of this as having two memory paths through. I think of C as the long-term memory path because it is possible to pass it through unmodified. And I think of H's as the short-term memory path because it modulates something like very quickly that then gets passed out. I mean, it is a little bit funny because the H's is like, it's derived, so the H at this time step is derived from the C at this time step. And so it's like, I'm gonna pick something out of my long-term memory and then use that, like some additional processing on it to modulate kind of everything I'm gonna do at the next time step. So to be perfectly honest, I think there's some really nice ideas in this LSTM block. I love the idea of learning to remember. I love the idea of learning to forget. I love the idea of explicit state management. I think it's a little complicated, a little overly complicated. And actually, a lot of other people in the industry agree, and that's why we've actually moved a little bit beyond these. And there's these other things called GRUs, which we'll also study, which are much simpler than this, and I think a little more direct. So, but this is like the classic thing. Okay, so yeah, so good. So learn what to remember, learn what to forget, learn what to forget, learn what to remember, learn how to, learn whether to remember it, learn what to remember. So tell me what this is all doing over here. What is this doing? Go ahead.
Is it letting the long-term memory have an opinion to give to the short-term memory?
Yes. So there's actually two things going on here. So this is, so notice where this is headed. This heads out, this is our output, but it's also like whatever you spat out at the previous time step gets fed into the next time step. So that's like the short-term thing that I'm remembering. I'm remembering the thing that I spit out. So it's doing double duty. And yes, then that has an opinion about everything I'm going to do at the next time step.
So like the input that you just gave it and the short-term memory from last time and the long-term memory all like vote to make a thing to spit out, and then we feed that into the short-term
Yes.
memory?
Yes.
Okay.
So right, if this was the word straw, then straw would come in here and it would know, oh, okay, I just spit out the word straw. Good, well then the next word I've got to spit out is going to be hat. And it would spit out hat, but then it would remember, oh yeah, I remember the last time I spat out hat. And so now I need to go ahead and spit out the next thing. And the long-term memory is remembering like the fact that I said straw hat like 10 time steps ago, and now I need to say fell into the pond or whatever.
Parentheses.
Yeah.
Yeah.
Good, yeah, so the thing that we spit out is a function of the long-term memory that we had, as well as our input, whatever it is, as well as the thing we spat out last time, our short-term memory. Yeah.
So is it true that in LSTM, in this case, the hidden state will always be between -1 and 1? Because we have the tangent there?
Okay.
Is there another scaling? I mean, and then we put a linear layer on top of that, is that kind of the idea?
Yeah, so, okay, so question was, does that mean that the entries in the hidden state will always be between -1 and 1?
Or at least not necessarily the C, but the H when it comes out because we have the tangent in the signal.
Oh, you mean right here?
Yeah. So like the actual net output that we use, the red nodes
Yes.
on top are always -1.
Yes, in this case. Yeah, go ahead.
So I'm just looking at it, and if we were to hook this LSTM up to itself,
Yep.
does that mean that the short-term orange row and the dark X row are the exact same? Like, would it just be counting that twice if we hooked it up to itself?
Sorry, what do you mean? Well, it is being hooked up to itself.
Because the X is the input, right?
X is the input, yes.
And if we made the output of the previous time step be the input, like if we were to roll it out like we were talking
Oh, like
about.
force this to be equal to xt?
Yeah, is that done in practice?
Sort of. So there's this technique called teacher forcing, which is kind of done. So you actually sever this link right here. And so it spits out some word, but then at the next time step, you pretend that it spit out the right word when you train the next time step. So, yeah, we'll see that as a technique in machine translation. Yeah?
Is it true that, so a single block has like 3 weight matrices?
Yep.
So- and-
Well, I think it's more like 5, right?
Uh,
So you have one here, one here, one here, one here, and one here.
okay. And is it true, so we're seeing like 3 blocks,
Yes.
but is it the case that the weight matrices are the same in each block?
Yes. So importantly, like a recurrent backprop through TimeNet, the weights are shared across time.
Yeah, this is like, could you say that this is unfolded now?
Yes.
Where it's really the same?
It's really, that's right. That's right. This is the same block repeated, unfolded over time.
Okay.
Good question. By the way, another thing that you can do, oh wow, we're out of time. So sorry. Another thing you can do is stack these. So you can take these blocks and you can imagine that the output of this guy is actually the input to another LSTM block up here. So you can stack them vertically and remember hierarchical things. And we won't actually do that, but you can do that. People do that all the time. Okay, great. Have a great weekend. Enjoy conference. Forget about deep learning for 2 days.
Is this video available somewhere?